what is neuromorphic computing? Can neurobiological structures be replicated to make a highly connected network like our brain?
Okay, yeah. So, as far as my understanding of neuromorphic computing goes, see, as I said, in our attempt to create intelligence, quote unquote intelligence, where do we take reference from? I mean, I'm talking, let's say, just rewind back like 100, 200 years ago. You want to create such a machine which can work intelligently, but the definition of intelligence that you have is again humans around you. So you try to understand human brain, and now by understanding human brain, you're trying to replicate the concepts into a model.
Yes.
So there is a famous work in mammal, basically researching based on mammals, which was done by Hubel and Wiesel. It is a very popularly cited work in computer vision community. Basically, they did experiments with cats, and based on their, it was a study performed to analyze the visual system of cats, assuming that cats are similar to human babies. And they made some observation based on which, those observations were leveraged, that which is utilized right now into our having a hierarchical structure of the CNN. That initial layers will have lower level features, and then the deeper layer will have a higher features. So in the initial layers, you will detect the edges, corners, etc. But as you move deeper into the layers, the shape of the object, let's say you're trying to detect someone's face, the shape of the structure of the face emerges into the later layers. Based on some biological understanding, yes, some ideas were taken to configure the networks in a particular manner. And as far as that goes, my point is that although we give it a different name, that's how it has evolved. But so to answer the first part, and the second part of that, can these neurobiological structures be replicated to make a highly connected network like our brain? So coming to this part, what we need to understand is that in whatever limited sense, when humans, let's say, have analyzed our visual cortex or our auditory system, and maybe some insight that we try to leverage to configure our modern models, that is always possible. But yes, there are some, but one could argue that maybe the biological way in which it is happening is inefficient. But here, what we are trying to do with this electronics is much more efficient. We can talk like that. But yes, there are some aspects of our human brain which are very interesting to AI researchers. So for example, memory. The way human brain deals with memory is very fascinating. And right now, our AI systems, I should not just say AI systems, but whatever systems we have where we have tried to have like a digital memory. So even having hard disk RAM, and even having some state which is saved while training of a network, all of that is trying to leverage that memory concept, but that is very, very primitive. So in such a scenario, it depends on our own understanding. If our understanding of efficient utilization of memory in biological brains increases, then those techniques can be leveraged definitely while designing such models. So, and this is an active field as well. Trying to leverage whatever studies happens with human brain and trying to see if that can give us some insight into our models. I can think of actually very interesting application which happened in the lab I was associated with at IIT Bombay. So here's the theory. The theory is that there is a I-mind hypothesis. So there's something called as I-mind hypothesis. So the idea is that, let's say, when you are reading a text, let's say either a newspaper or on your screen, when you're trying to read let's say a text which is full on your screen and trying to read a text which is, let's say, humorous, okay, versus a text which is somewhat tragic in nature. So just by tracking your eye movements, one can predict to a decent extent what kind of text you are trying to read. So a lot of this work was done in my lab by one of our senior researchers of our lab, Dr. Abhijit Mishra. He's right now in US working with Apple R&D. So he worked on this field of research is called as cognitive NLP. So based on your eye movements, how can you improve the sentiment analysis system, or even natural language generation, machine translation, or whatever. So the point I was trying to make with this example is that an observation based on our own mind, that our eyes and our mind, the decisions our mind is making, is reflected or can be captured to a decent extent through our eye movements. And that is why even we as humans, when we are talking to someone, we can see that, oh, the person was happy during our conversation, or he is sad, all of that. Definitely there are other markers as well. For example, our cheeks, our smile, all of that. But just even by narrowly focusing on eyes as well, we are getting a lot of information. So that concept has been leveraged, and AI systems are being built using those leveraged concepts. So this was just one example to outline that fact, that as our own understanding of our functioning, our brain improves, yes, AI community is ever ready to include that insight if it is definitely helping us to achieve an efficient AI system.